Welcome to the lesson on electron configurations. Today we're going to learn how to read electron configurations, and then Friday in class we're going to learn how to write them. So an electron configuration is a notation that's used to show what sublevel and energy level each electron is in an atom. So below here we have the electron configuration for neon. If you look at your periodic table, neon's atomic number is 10. And when it's in its neutral form, it has 10 electrons. And what's given here is the electron configuration for neon. What this means, okay, is that the big number tells you the energy level the electrons are in. The letter tells you the sublevel. And the superscript, which are these little numbers at the top, tell you the number of electrons. So what this means, if I read it out loud, is that in the first energy level, in the S sublevel, there are 2 electrons. In the second energy level, in the S sublevel, there are 2 electrons. And in the second energy level, in the P sublevel, the second energy level, in the P sublevel, there are 6 electrons. So the big number, which is called the coefficient, tells you the energy level. The letters tell you the sublevel. And the superscript tells you the number of electrons. Now it says on the bottom, using the electron configuration above, tell how many electrons are in each energy level. So, if we look at the first energy level that we have is the first. Okay? So in the first energy level, we look at every sublevel that has a 1 in front of it. So this sublevel, the 1s sublevel, has a 1 in front of it. And there are 2 electrons. There are no other sublevels that have a 1 in front of it, so the first energy level has 2 electrons. Now we have the second energy level. Okay? If we look at the second energy level, this one has a 2 in front of it, and this one has a 2 in front of it. And if we add up the electrons, there are 2 in this sublevel, and there are 6 in this sublevel, for a total of 8 electrons in the second energy level. Alright, we're now going to look at a little bit longer electron configuration. So, again, it says how many electrons are in each energy level. So we're going to look at the first energy level, and we're going to circle any sublevel that has a 1 in front of it. This is the only one that has a 1 in front of it. So in the first energy level, there are 2 electrons. Okay, then we're going to look at the second energy level. Okay, and then we're going to circle any sublevel that has a 2 in front of it. This one has a 2 in front of it, and this one has a 2 in front of it. And if we add up the electrons, 2 electrons here, 6 electrons here, that's a total of 8 electrons. Now we look at the third energy level. Okay, we circle any one that has a 3 in front of it. For this one has a 3 in front of it. And this one has a 3 in front of it. So that's a total of, and there's 2 here and 6 here, so that's a total of 8. And last but not least, we have the fourth energy level, which I'm writing this using the mouse, so that's why it looks so horrible. And here's the only one with the fourth energy level in it, and then there are 2 electrons. Now you may be saying, well, Miss, it didn't completely fill the third until it went to the fourth. Don't worry about that now. That's where Bohr was wrong. Alright, so it's not in the excited state. Okay, we'll talk about that Friday in class. Okay, now, what is the highest occupied energy level? What that means is what's the highest energy level, the highest big number, okay, big coefficient that has electrons in it, and that's the fourth. The fourth energy level is the highest energy level. Okay, the next question is how many valence electrons does the atom have? If you remember, valence electrons are the number of electrons in the last energy level. The last energy level is the fourth, and there are 2. Draw a dot diagram of the element. So a dot diagram shows the symbol of the element and the number of valence electrons it has. And I'll talk about this more on Friday. But to find the atom, you have to count the total number of electrons. So 2, 4, 10, 12, 18, 20. So there are 20 electrons, and if you look at your periodic table, that makes it calcium. So you draw the symbol for calcium, okay? And for a dot structure, okay, you put around the element the number of dots that it has valence electrons. So this guy here has 2 valence electrons, okay? When it has 2 valence electrons, you put them together on the top. Okay, we're going to look at another case when it's not 2. So 2 is an exception. When there's 2, you put them together on the top. Okay, and that shows the valence electrons. We're going to see an example where we don't put them together on the top, I think in the next case. So if the element is neutral, what element is it? Well, we just figured out it's calcium. Okay. Now the question on the bottom causes the most problems for people. Okay. And it asks, if the element has a +2 charge, what element it is? Well, you know, since these represent electrons, that it has 20 electrons. You know that. Because these numbers here represent electrons. So in order for the element to have a +2 charge, it has to have 2 more protons. So we add 2 to that. Okay? And that means it has an atomic number of 22. Which it's hard to write 2's with mouse. If we look, the element that has a atomic number of 22 is Ti. Okay? If we have trouble with this, we'll talk about it a little bit more on Friday. Alright, we're going to do one more example together. And then your homework is to do that one that follows. Okay. So, again, we have a longer configuration. So if we take a look, I want to know how many electrons are in each energy level. So what I would do if I were you, I would pause the video right now and then see if you can do it yourself. And then check your answers. So in the first energy level, if we take a look, this is the only one with a 1 in front of it, and it can be the only one. So the first energy level, most of the time, always has 2 electrons in it. Second energy level, okay, we have this one and this one with 2's in front of it, and there's 2 and 6, so that's a total of 8 electrons. We have the third energy level, which is here, here, and here. Okay, don't worry about the order right now, we'll talk about them Friday. So that's 2, 6, 10, so that's a total of 18. And then in the fourth energy level, that's the last one that we see, you got here and here, and that's a total of 2 plus 2, which is there are 4 electrons in the fourth energy level. How many valence electrons does this atom have? Remember, valence electrons are the number of electrons in the last or highest energy level. The highest energy level is the 4th. Alright? And in the 4th energy level, there are 4 valence electrons. Now it wants us to draw a dot diagram, so we have to count the electrons to figure out what symbol it is. So 2 plus 2 is 4, plus 6 is 10, then we got 12, 18, 20, 30, 32. So if we take a look at the 32, that makes it GE. So if I can make a G, that's our GE. Now, you only put the electrons on top together if there are 2 valence electrons. When there are 4, you put 1 on each side, or anything other than 2. You put 1 on each side, and then you double up if you need to, but we don't need to double up. So our dot structure should look like that. And then last but not least, if our element is neutral, what element it is, we just figured that out. It's G. Alright. So what I would like you guys to do is do the page, which is another one. And then we'll talk about, I won't probably grade that. I'll make sure that all the questions are done, but I probably won't grade it for right or wrong. And we'll talk about it in class on Friday. But I will see you guys on Friday.